xy. So something you have to be saving this to see if there's an error. I have an error on line 29. I have multiple errors on line 29. What did I do on line 29? Negative edge. So let's put a comma here. Line 39. Okay, so we are still getting through this. Excuse. So in this nested case, we have case xy. So now there are two scenarios. xy could be, let's say 0 0, or xy could be 1 1. So in both of these cases, 0 0 1 1, if we look at the state diagram, 0 0 1 1, what happens? It means let the state be S0. So S0, right? And also we could have another possibility where I'm just gonna copy these, and where the state where xy is 0 1 0 1 and xy is 1 0 1 1 0. Yeah, this is right here, 0 1 and 1 0. Now the state in this case, the next state, we're working here on the next state. This is supposed to be the next state, because this block here forms the next state. So the next state is S0, and in this case the next state is S1. It's S1. Okay, now we have, this is the case for S0. Now let's go to S1. If we have S1 as the next case, then we get after doing this, we have to end the case for the inner case. Then we go back and say, let's define another case. You know what, if you know what you're doing, it's not always advisable to copy code and paste, but if you know what you're doing, you can just easily copy it and paste it. We're supposed to do the same thing here, and do the same thing here. The only thing that changes in this case is that this becomes 1 0 1 1 0, and this becomes 0. So it's good to copy code and paste, but you should understand what you're doing, what you're copying and pasting. So that is that for and then you should end the outer case, and the outer case. So since it's always good to, since you're working with a big compound statement, so it's good to like begin and end, or use fork and join. So this is our code or HTML description using Verilog for this circuit. Is based on the behavioral model. Let's see how it works out. It's been saved. Let us try to see the syntax. Let us run it. so here we are. We're just gonna test. Let's check the syntax of the description. Let's just see. That is, let's check if the syntax is correct. So the syntax is correct. So what next? We have to write a test bench. We have to simulate the description, the design. So let's add a test bench. Just use the Verilog test feature, and we're going to call it test problem 5.28. Associated source is problem 5.28. You need to associate it, and next state, and finish. So here is what we have as the model. So the Xilinx program does this for you. For all the inputs, it defines the rec, it defines the register, and then the output, it defines it as the wire, and it instantiates the unit under test. Then here is the, you can just delete all of these and put in your own stimulus. You can have stimulus and all these things. You can delete all of this, no problem. So the first things first, in the test bench, we want to define, after doing all of this, the register, the wire, and the instantiation, we want to define our clock, because we need the clock to power any sequential circuit. So we just use clock to define a clock. We use the initial block or the initial statement. We say initial begin let initially the clock 0, and we want this clock to run forever. If there is any stimulus, let the clock continue to run, and for every 5, that is for every 5 nanosecond, let the clock be complement the clock. And so this is the clock with period 10 nanosecond, because the clock moves from 0 to 1 in 5 seconds, and from 1 to 0 in another 5 nanoseconds. So this is a clock of period 10 nanosecond. Yeah, so that is the clock. We've done that. So we want to it's always good to use fork, because I combine that. You want to use fork here. We want to use join. So first things first, we need to now the question said here we go. Write an HDS stimulus with a sequence of inputs 0 0 1 0 1 1 and 1 0. So here we go. So let's just say, let's get this way. So first things first, we have to initialize the circuit. So we need to set reset to reset 1 means off. Reset 1 means, if you say reset 1, the circuit is off, and reset B equal to 0 means clear the anything to 0, set the state, clear the state to 0. So this actually clears the state to 0. That is, it actually initializes the state. And now we can now, so this could run for maybe, like, I don't know, let this run for a very small time, 2 seconds. This could run for, you could just run this for after 1 nanosecond, it doesn't matter, after another 1 nanosecond, just change these. So this is what happens, and then let us run the, so this actually clears the state to 0, right? Or you can see it initializes the state. That is why you need a reset for this thing. And so now we need to initialize the inputs. So x is equal to 0 and y is equal to 0. No, it's a statement on its own. There's another statement on its own. So now let's say the one that is done after, like, let's say after 10 seconds, after 10 nanoseconds, we need to give this thing a signal. Begin reset. So we've been given a sequence 0 0 0 1 1 1 and 1 0. So we're going to say let x equal to 0, y equal to 0. That's the first thing, and do this again, but this time around the next input could happen after 10 seconds, 10 nanoseconds, because everything here, all the time here is nanoseconds. 0 1 0 1, you can paste this again. There's no need to indent anything here. You place this again, and you have this time around it's 1 1 1 1, and this time around it's 1 0 1 0. So that is our stimulus. Happen after 10 seconds. So that is our stimulus. I think that's all we have. And so let us check the syntax of this. This is a test for this. Let us save it first. Save it. Let us check the syntax and see if there's any errors or warnings. No errors, no warnings. So let's simulating. So here is a simulation. Oops, there's a problem. There's a problem with the output. The output doesn't change. The output is showing don't care or true. So let's go back and check there's something wrong. There's something wrong. Let's close the simulator.